Hi, my name is Kitawat Thongpun. Now I'm going to present about the summarized idea of the pendulum control that add the intelligent system like fuzzy logic at the chapter 5. In this project, it's called the pendulum project that used to control the pendulum. And before we go in the detail, we have to go in the setup pendulum section. First one, we have to set the potentiometer. The potentiometer is a sensor that used to feedback the degree of the pendulum. The potentiometer is the rotationless, limitless rotation type of the potentiometer. If you can rotate around, no limitation. And then we have to set the belt to check that the belt is tight enough to use with the pulley system or not. Then after that, we check the belt. We have to check the slot of the pendulum. The every nut is tight or not. And this one is the schematic diagram of this project. By the way, this project is it have a HB motor controller that connect to the extension board. The extension board is have a input of the potentiometer and the motor encoder, and we connect to the LabVIEW MyRio. It's the same from the chapter 4. Every project for this class is a project about the LabVIEW MyRio. And then I start the fuzzy logic design. I decide as the position error. Firstly, I have to define the input or input output of the fuzzy logic control system. For the input variable, I have the position error and position diff. The position is the position of the pendulum. By it have the 6 element that form the large negative, medium negative, small negative value at the zero length value, small positive, medium positive, until the large positive value. And in the same way, the position dip is have the 7 element is like the same of the position error. For both input is used to consider the control output as the I expect to use to control the PWM of the motor. And at the same way, the output is have 7 element that large negative, medium negative, small negative, 0, small positive, medium positive, and large positive. And for the rule base for this controller, I have drawn the table. The table that is have it have error is in the large negative. Is the small letter for LN. MN is for the medium negative, and SN is for small negative. In the same way, it's for the SP is the small positive, medium positive, and LP is large positive, and C is 0. And then I expect that if the error and dip is if it have too much in the minus, in the negative, I need to move the position of the pendulum in the anti-direction of the diff from the velocity of the pendulum, omega of the pendulum. I try to use this rule to anti the swing of the pendulum by control the position of the guide of the belt move the in the opposite direction from the swing of the pendulum at the max speed. And this one is the system test, like a system diagram output input output relationship of this facility design. And in the VI it have for my lab view, in the VI it have a control in 3 mode. It have manual mode used to controls the PWM directly. And next one is auto mode. Auto mode is used to control the set point of the pulley of the pendulum by using PAD. And then the last one is the fuzzy, using fuzzy control mode that I have presented before. It will try to anti swing of the pendulum degree, rate of change of degree of the pendulum. And for the left side, it have two main menu as monitor menu, like for this one. And for another one is the setting menu. For the setting menu, have a motor setting. It used to limit the length of the motor. It's like a safety. It's like a safety length for the motor, that the pendulum the pulley is not broken when rotate more than the limit. It can have a damage. And have a reset counter, like if I shut it down, I unplug it and I move it by hand, the position will change. This one is help to change the position. I like reset to 0, used to calibrate. And then for pendulum is have parameter for the remap. The pendulum input as the potentiometer is for 0 to 5 volt, and I have to remap to the new length is 0 to 360 degree. And I add the sum is called offset degree. Like if I no need to rotate the potentiometer in the correct way, I have to offset it. And filter type. Now the filter are for this data, as I told you in the last section, the propeller project, it have to filter the data of the potentiometer because it have many swing data. To control, we can control the swing data easily. Then I use low pass to help it. It have to set the sampling time, the low cutoff frequency, high cutoff frequency. Yeah. And for this section is about the pendulum, the block diagram of the pendulum project. And this one, I start with the top. It is at the same is a timer. It's the timer section used to set the time response of this system. And then go to the middle one at the left side to right side. Input the sensor from Mario as the ADC input. It's the pendulum and pendulum angle. At 0 to 5, it's go to calibration, remap it, go to the low pass filter, and then monitor. And for the encoder, I have the add the reset counter that I told you we have to reset it to initialize it, and the counter value output for the in data. And in the monitor, I will use the local variable that used to pull the data. Like I no need to the drag many line, then I use this one, make it shorter. Maybe it look beautiful. And for the bottom is the control, the mode control. For now, the left bottom one is the manual control. The manual control is the slide bar used to control the PWM that sent to the H-bit controller sub VI and then output to the direction A, direction B of the H-bit controller, and also PWM for the H-bit controller. And this one is the auto mode from the case structure. The auto mode is we input as the encoder counter and set point. The set point is used to set the position of the motor, where is to pull, how many to pull it. And then the input length is 1000, the minus 1000 to 1000, and then I rearrange it to the 0 to minus 1 to 1, that to use to send the signal control to the H-bit control. And this one is the fuzzy system, the fuzzy mode. The fuzzy mode that we have a fuzzy controller that input from the fuzzy that I have introduced before, and then input as the pendulum angle, the diff of pendulum angle, and then the pendulum angle error, like a position dip and position error is the input for this controller. And then send the output for the controller. I forgot to say about the output is the length of the minus 1000 to 1000. I use look like at the PID. I have to relink it to the minus 1 to 1 with the 3 digit. And then I send this one in the same way as the PID control. I send it to the controller, and this one is the sub VI of the H-bit control. This sub VI I use to input the control, and this one is also be the safety control, like it have input for the encoder counter, the control speed and max speed, like this one is have a limit max and limit min. Is used to the safety of the motor. First, for in the sub VI, left side is controller, used to control that which way the direction used to be. For the H-bit control, we have to set direction as a 10 or 01, and this one will generate the will process the control speed that have a length minus 1 to 1, and check it which one is have to be direction as the direction A and direction B. If no both, it will be the 1 1 or the 0 0. And then go to the safety. The safety is the check section that the motor have rotate more than the limitation or limitation max or min or not. If in the length that allowable, the safety in that direction will can change normally. But if not, like if the B is the direction for the like if b is 1, is the direction for move like a 0 1 is the direction to move to the left side. If the left side is the limit max of the encoder rotation. If it's more than that, it's the safety, the direction b will always be 0, and it's in the same way that the the b will be 0. It means it can control just 1 0 for direction a and b. 1 0 is used to safety control direction and output as a PWM. Direction A, direction B as Boolean is the work principle of the sub VI named H-bit control. And this one is for the operate result of this section. Now I try to swing it and try to swing it. Yes, as you see, is we try to swing the pendulum, and it try to anti the direction of the swing. If we move the invert. And for this one, is another one. The pendulum with PID, the pendulum font VI. That's the subsequent have it done in another way. As for me, as anti swing for the pendulum control. For this one is a PID control for the pendulum. And this show the changes of the VI is the controller part. The controller part is have a cast set point as a PID. It have two PID is tilt set point and cast set point. As the length of the PID is the same, is 1000 to minus 1000, and relength it and go to the sub VI. Oh, now it did not create a sub VI, but it's the same, and send to the control to the H-bit control and generates the control motion signal. And this one is the example, the result example. Okay, I try to open it. Okay. Okay, and it's the all of the chapter 5 that we have the finished now, and thank you for watching.